Okay, we're going to look at our complex factors of polynomials this lesson, but we might start off with just looking at some real polynomials, and then we'll extend it from there. So if I was to look at the polynomial x plus 5 multiplied by x, take away 2, if I expanded these brackets out, I'd have x times x, which is x squared, x times negative 2, which is negative 2x, 5 times x, which is plus 5x, and positive 5 times negative 2, which gives me negative 10. If I simplify that, I'll get x squared plus 3x, take 10. Now what you can see from here, that this expression here is exactly the same as this one. It's just expanded out. And if we were to substitute in a value of negative 5 for x here, then it would make this expression equal to 0. Okay? So if I was to substitute negative 5 into here for x, then again, it would make the whole thing equal to 0 as well. Right, same idea here, because I've got x take 2. If I was to use positive 2 for x here, if I substitute 2 in, it'll make the whole expression equal to 0. And so if I substituted 2 in here, it'd also make the whole expression equal to 2 as well. Okay, you could check it by substituting it into here and making sure it does that. So we might just do that. Let's just use the simple case where x is equal to 2. Okay, so we'll end up with 2 squared plus 3 times 2, take away 10. And when we do that, we get 4 plus 6, take 10, which gives me 0. So we can see that it does work if I use that technique. And we're going to apply this same sort of technique to complex numbers. All right? And we've got verify that z take I and z plus 2i are factors, just like x take 2 and x plus 5 were our factors before. These are the ones that we're checking to see if they're factors of this expanded expression here. Okay, so that's our first step. Now, if they are factors, then each one of these should equal 0 when I substitute a value in for z. Okay, so I'm looking at if I put z is equal to I take I gives me 0, therefore this whole expression here would be equal to 0. Okay, so let's check that that is the case. So I'm going to look at pi is 3 times by I to the power of 3, take away I times by I squared, plus 10 times by I, take away 8I. Now I cubed is negative I, so we'll end up with negative 3I there. I squared times by another I, again, it's the same as I cubed, so it's going to be negative I, but I've got a negative here, so it's plus I. Plus 10I, take 8I. Okay, so if I have negative 3i plus I get negative 2i plus 10, I get positive 8i, take away 8i's, we end up with 0. So I can therefore say that z, take away I, is a factor of pz. Okay, so we know that this z take I must be a factor, because if I substitute in I for z here, that'll give me 0 there. And if I substitute I in here, it gives me 0 as well. So it must be a factor. I must be able to replace this function and write it in terms of its linear factors, with that being one of those linear factors. All right, let's check the next one, z plus 2i. Now, for it to equal 0, z would have to be equal to negative 2i. So let's substitute it into this function here and check that it equals 0. And if it does, we know, again, that it must be a factor. So p of negative 2i. So everywhere I've got z, I'm substituting in negative 2i. So I'll end up with 3 times by negative 2i to the power of 3 plus, sorry, not plus, take away I times by negative 2i to the power of 2 plus 10 times by negative 2i, take away 8i. If I expand this out, I'll end up with 3 times by negative 2 to the power of 3 is going to give me negative 8. I cubed is going to be negative I. Then I've got take away I multiplied by negative 2 squared, which is just positive 4, multiplied by I squared, which is the same as negative 1. Then I've got 10 times by negative 2, which is negative 20I, take away 8I. Okay, let's simplify this. So 3 times negative 8 times negative I gives me positive 24I. And I've got a negative and a negative, so I've got plus here, 4i, and take away 20i, take away 8i. Now look at this, 24i's plus 4 gives me 28i's, take away 20, then take away another 8, and we're at 0. So I can therefore say that this z plus 2i is a factor of pz.